Hey, what's up? It's Jake, and today I'm going to be going over immutable sequences with strings and bytes. So, um, let's go ahead and get into this. It's a little bit of a complex topic, but I'll do my best to simplify it. So, text data or textual data in Python is handled with strings, as we've seen. So, if I go into a shell here and I want to make a string like name equals Jake, uh, this has a value of Jake, and if we look up the type of name, we can see str is a string. So these are immutable sequences of something called Unicode code points. So this is something I have not seen come up in a Python course before, so we'll go ahead and camp out here for a little bit. Unicode points can represent really any character, but they also have other meanings, like formatting, for example. Python is different than other languages in that it doesn't have a char type, and the char, CHR, is short for character, and a lot of other languages have a character type. So a single character as rendered in Python is simply just a string length of 1. Um, Unicode is a good way to handle data, though, because it's used for the internals of any application. So when you store textual data, like I did here with this variable name, um, uh, you would want to encode it when you're sending it across a network. Okay. Now, in order to do that, you have to use an appropriate encoding medium, and the result of the encoding process produces bytes, an actual bytes object. The syntax is similar. The behavior is similar to strings, and what we call string literals are written in Python and use as you see here, the double quotes, or I could make a single quote here, age single quote 39, and that does essentially the same thing, right? So you can use double quotes, or you can use single quotes, or you can even use triple quotes, and the triple quotes would allow you to span multiple lines. Okay, so if if I had a I don't know, address equals, and then I could do like triple quotes like that, and then say 123 street drive, enter, and then I could be like Anytown, USA, enter, my zip code 11111, triple quotes, enter. And then if I called address, it calls in the address, and the /n is a return, carriage return, which basically says new paragraph. So it would represent this as 3 different things. So you'll notice that you probably don't want to see it like this. You want to see it with new lines. And this is kind of where we get into spanning multiple lines, and there's different ways to do that. So instead of just calling address like I did, what happens if I print address? Oh, look at that. So the print functionality actually executes those carriage returns, those /n's, to create new lines. So depending on how you're returning your data, you may get it in this format or you may get it in this format, and you just need to decide what is it you're trying to get and make sure that you're using the proper method for getting the data in the format that you want it. So those are 4 different ways to make a string. You can do double quotes, you can do single quotes, you can do uh, the triple quotes. Well, the 4th one would be the same thing but using triple single quotes like that. So you could do that too. If I said like favorite underscore colors equals text like that, and then I could say blue, red, white, and then call favorite colors. colors, and you can see it like that. Or you could print favorite colors and see it like that. So those are the 4 different ways to represent, to make a string, and how to span multiple lines or have a multiple line string span one line with carriage returns. One of the other things you can do is you can use the length. So strings, in this case, we're talking about immutable sequences, right? So this is technically a sequence, and every sequence has a length. So if I wanted to get the length of my name, I could type len for length, that's the length function, and go name, and see that my name has 4 characters, or is 4 characters in length. And this is super useful. This is actually used a lot, so definitely play around with lengths a little bit and get used to it. Remember that function, because you will end up using it a lot. So before I go any further, one of the things I want to talk about is, well, we'll do one more thing. So there's 2 other methods you can use to deal with textual data, and I'll go ahead and clear this screen here. And that is by representing suffix and prefix when you're trying to drop things. So if you've ever used Excel or a spreadsheet of some kind to try to say, hey, I need this, but I need to drop like the first 3 characters, or I need to drop the last 4 characters, or something like that. You can do that in Python too. So let's make a string. String, we're going to name it S, and we'll just say, hello there. Okay. And what you can do is you can go into this namespace and say, remove prefix. And let's say I want to remove the HE part. Okay. And if I do that, it's just going to give me the rest. Low there. So just like you remove a prefix, you can also remove a suffix. And I bet you'll never guess how you do that. And if I wanted to remove the suffix ERE, it would return hello the, right? And what it's doing is it's looking at your text and as a data, right, as a piece of data, an object, and says, do these characters HE exist? And if they do, identify them and their position in this string and drop those characters. So what happens if it doesn't find something? Well, let's try to remove a prefix. So I'm going to say s dot remove prefix, and let's do something that doesn't exist, like a something like that. And it will just return hello there because it doesn't exist, so it doesn't actually drop anything. So the nice thing about the last instruction, like I said, is if you attempt to remove something that's not there, it will just return a copy of the original string, which means that behind the scenes, it's actually checking the prefix and suffix match against the argument of the whole, what's called a call, like when you call that function s.remove prefix, you're calling that. And if it's there, it'll remove it, and if it's not, it won't. So that's a little bit of string manipulation, right? And we're referring to these as a sequence, right? So this is a sequence. This text is a sequence. It's a sequence of characters, if you want to think about it that way, or a sequence of bits. So let me go into one last topic, which is a little bit more complicated, and that is dealing with strings, because there's a difference, like I was showing you. Let me make this bigger. So if you make a data type, or if you make a variable, say we'll just say S for sentence, and that sentence is hello from Python, right? And if we return this S, we get this version, but if we print S, we get this version. And you might be wondering why that's different, right? So I actually wanted to break this down a little bit, and what it comes down to is the difference between 2 different functions, internal, like built-in functions, One is the str, which we've been using, and the other one is called repr, okay, to reproduce or represent an object. So in Python, the built-in string and represent functions produce a textual representation of an object. This is a textual representation of this object right here. This is a textual representation of this object S right here. So let me give you another example that is even a little bit stranger. So I'm going to import something called datetime, and you can use this in your own programs or scripts or whatever whenever you need to refer to dates. And I'm going to say that today is datetime dot now. So whatever right now is. Okay, now if I print the string version of today, so I'm specifically saying print the string version of today, I get 2022-03-03 and then the time. And then what would happen if I printed the representation version? Well, if I print the REPR of today, it's a different output. So you get datetime.datetime and then the same values with comma separated spacing. But they're the same, like interpreted, we interpret that as this basically the same thing, but they're not the same thing. The difference is the string function returns a much more readable version of what a human would expect to see describing the object today. And the represent function returns a developer-friendly string representation of the same object. So now that you've seen that example, let's talk about how they work. So when you call string, okay, like that, on an object, it calls a special method. And if you remember from when we were making classes, here, I'll start doing this up here. I'll make a fruit class. Okay, I always talk about oranges and stuff. So you see me do define init before, right? And I do self and then like the name of a fruit or something like that. And then we would do something like self, because self is already defined, but name is not. Self.name equals name, right? And then I might set name as orange and then call it, and it would do that thing. So let's try that and see what happens. So let me clear this out here. And so I'm going to make a banana equals fruit, calling my class, and I'm just going to name it banana. Oops, what is that? Oh, because I didn't actually make this. Let me just copy this and paste it in here. Oops, paste. And then now let's go. Fruit banana equals fruit banana. Now I should be able to print banana. And what do you think is gonna what do you think is gonna print out? Yeah, but you didn't see that coming. So what happened? This is kind of like an unambiguous object, right? And you'll hear in explanations of this, which is why I didn't use this word to define what representation is it'll say it's an unambiguous way of representing a string, right? And then the string is the human readable version of it. So the default string representation of this object, banana, is, in this case, well, it could be string or RPR, right? REPR. So if you provide it, it will produce what you want. And so you always want to be very intentional about what it is that you want, right? So if I were to edit this class and say, okay, yeah, we have this initialized name, but when Python calls this function, it's going to do everything inside of here, right? So let's actually define string as a method. So the string of myself, whatever I'm passing this, so in this case like banana, I want to return, and then F is just a fancy way of returning this. I am a, and then in curly brackets, I can do self.name, and it will just produce the name, something like that. Okay. And then I can also make another one that says, okay, let's do REPR as well for self. And let's return, let's return F fruit, and then in quotes, self.name. If you don't know how I'm doing this, that's okay. Just try to follow along as best you can, just in the context of this. Yeah, there we go. So it should return banana, right? So yeah. So now if we take this same class and I just create this sucker down here, and I try the same thing. I say banana equals fruit, and then we'll just call it banana. And then we want to print banana. Now what do you think is going to happen? So if I'm saying banana is, use the fruit class with the name banana, it's going to come into here, not into like this file, but I just typed it into the interactive shell. I'm just using this file so you can read it a little easier. So it's going to come in here and say, okay, I am self a fruit, and the instance of this fruit is a banana. The string of myself, if called, returns I am a banana. The RPR version of myself returns the fruit name, which would be just banana. So we should see I am a banana or banana. Now, what does print do? Well, if you look at the source code of print, which I'm sure you'll never do. Let's see if I can get this up here. Can I get this self? No, I can't. All right. That'll take too long. The actual source code of Python, so like in C, what it does when you're printing is it's printing the string version. So in this case, if it's printing the string, it should return I am a banana. So let's see what happens when we print banana. I am a banana. There it is. Okay, so what happens if we do something a little different? Let's see here. So if I'm printing, let's see here. Let's print the representation of it. So the print function calls a string method of the instance, right? So the instance is banana, and it's going to call the string method right here of the banana, or of the object, the instance being the banana. So its name is banana, and it's going to return this. It's kind of like if this is true, return this, and it's getting this, so it's true. So what happens if we do this? What if we did print banana dot underscore underscore string underscore underscore, like that? So what do you think that does? Without even knowing what Python is doing right now, because you're very new to this, what do you think this does? Well, it's going to take the banana namespace, right, this object, and it's going to go return whatever this property is. So in this case, this would be the property, and we should get the same exact output. And we do. I am a banana. So what happens if we did just print string of banana? Well, first you have to type it correctly. Print string of banana. We get I am a banana. So it returns the same thing again. Okay, so if you call the string of banana, it's the same thing as calling banana dot underscore underscore str underscore underscore parentheses. So there's different ways to do that. And you may be able to do the same thing here and say REPR, right? And you get fruit banana. So you're just calling different parts of this class inside of it, depending on which representation you want. And in some cases, as a developer, you'll want this representation because it's easier to work with. When they say developer friendly, if I use the date time thing, as an example, if I'm coding something and I'm trying to manipulate textual data like a string, if I import date time, and then I say today equals date time dot now, and then I just say today, I would much rather have this because I can use this much easier than saying that. This is harder for me to manipulate because this is easy. I can go to the year and then go over 3 commas and then grab that number. This one's a little bit trickier, right? So that's a little bit of the in the weeds, the difference between different ways to represent strings. And I hope that makes sense. I think it makes sense. But yeah, so that's pretty much it for that part. The next thing I need to get into is encoding. So when if you're going to encode this stuff or decode, you can encode that with something called UTF-8, which is like the most common character encoding device. And it's widely used like all over the internet and stuff. And if you add the literal in front, like B in front of a string, you can create a bytes object. So now that we've been creating all these strings, and you're getting a little bit more familiar with strings, let's say I make a string that just says this is Unicode, right? And then I go, what's the type of this object? It's a string, right? So now if I want to go encoded, I want to make an encoded version of this string. I'm just going to make a variable called encoded underscore string, and I'm going to say string, right? S is my variable. Dot. I want you to encode that, so I'm just going to say s dot encode, and I want you to use UTF-8 to do it. Okay. And now if I return encoded s, there's a b in front of it, right? So this tells you it's a bytes object. So let's check that out. So let's go to type encoded underscore s, and the class is bytes. So I've converted this, I've encoded this in a way that's easily represented. So if you're transferring data across a network, it's good to encode the data encapsulated in that network transmission so that it's very readable and understandable through a method such as UTF-8 that everybody understands. Okay, it's like speaking a universal language. Yeah, so that's one way to do it, right? You can also decode it, and you'd never guess how to decode something. I could say encoded s equals s dot decode. Same thing. Oops, it has no actual encode. I need. Oh, I just need to take this. This is what I need to do. Encoded, and then in that namespace, I'll go or underscore s dot decode UTF-8. That should work. There we go. This is Unicode. So no longer has the B. And if I got the data type of encoded S, you'll see it says bytes, right? But I decoded it. I can read that. It's much easier to read. So the part of this, when we're talking about dropping off, well, that's it for encoding. The last part, or the next part, is when we're talking about dropping off indexes and suffixes. You remember, or prefixes and suffixes, we did that. This is kind of a form of something called slicing, and you have indexing and slicing that work together to understand where you're dropping characters. And so if you're going to manipulate a sequence, okay, a string, a sequence, it's common to access everything one position at a time, which would be like an index. Okay, so if I type the sentence s, and I'll say, make this a little taller. No, make it taller. There we go. If I said a sentence was whatever you want to say, I like to eat bananas. Okay, that's my string. Now an index would be what is like the first letter. All right, and remember in computer science everything starts with position 0. So all you would do is say S, and then in these straight brackets put a 0, and it will return the first character of this sequence. So instead of calling this a string, okay, for this point, I'm going to call this a sequence. It is a string, okay, this object is a string, but this inside this string, this is a sequence of characters 0 through whatever. So if I grabbed 1, index 1, you'll see it's blank, which makes sense because there's a space here. So in theory, then 2 would be an L, right? And it is L, okay? And we remembered that we have this length function. So the length of S is 21. There's 21 characters. So what happens if I go S21? Uh-oh, it's out of range. Now, why is that, do you think? Because although there are 21 characters, 21 is counting 0. So the last index position would actually be 20. So it's 0 through 20. So you have to go S20, and then you would get the S from this sequence, which is the last character or the last positional index. So when you're dealing with immutable sequences, you got to remember everything is read-only, okay? You're not really manipulating the sequence. You're actually just manipulating how you're reading the sequence. So it's important to understand that. So we have this 0-based access to any position in the sequence. And you can use that to kind of get into a different concept called slicing. So slicing is when you just get a piece of the sequence, just like we did with the prefix or the suffix. But we can be very intentional which part or which slice we want. And there are 3 parts to a slice. You have where it starts, where it stops, and another thing called step. So like, how do you want it to read? And I'll explain that. So everything's separated with a colon. Okay, so it would be like inside of here, you'd have a start, a stop, and a step. So it would kind of look like that. You can imagine it would look like that. They're separated with a colon. We can make a sequence and see what happens. Now, technically, this, I said, is a sequence, right? So we're going to use this sequence that we already made and add some different arguments, which is what we call these here, S0, 1, 2. We're passing arguments. And we're still going to use these straight brackets, and we're going to start trying to do some different slicing. So if I said S4 colon, what that would mean is, remember the very first one is start, and then colon, and then stop, colon, step. Well, I didn't put a stop or a step. So in other words, I said don't stop or step, just start. But I want you to start at index 4. Okay, so what does that mean? It means that. So it's going to start at index 4. So if position 0, the space is 1, L is 2, I is 3, K is 4, right? But we see that it actually does produce a K, right? And that's because we want it to be starting at 0, 1, 2, 3, 4, right at 4. So up to like at including this. Okay, so this is how you would basically drop the first few characters. All right, so you're not asking it to drop them. You're actually asking to only include everything after and including the 4th character. Hopefully that makes sense. You could do the exact opposite too and say start. I'm not going to put a start. I'm just going to say blank colon and then stop at 4. And if you do blank, it's going to start at the beginning and it's going to stop at 4. So 1, 2, 3, 4. So there we are. We have 4 character. Oh, I did say this includes 4. It does not include this one. It does not include 4. This one does include 4. So 0, 1, 2, 3. No, sorry, I have it backwards. 0, 1, 2, 3 does not include 4. This one does include 4. I was not using zero-based indexing. Just remember that. So yeah, the colon at the beginning doesn't have a start, so it's going to start at the beginning. Now, what happens if I do 2 numbers? So if I pass a position of 3, right, which would be 0, 1, 2, 3, the I, and I put a start of, I don't know, 14, it just grabs position or index 3 to 14. So let's look at what it includes. So position 3, we have I is 0, the space is 1, the L is 2, the I, little I, is 3. So it includes the third index here, right? But if we keep counting, K is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The B would be 14. You'll notice here it says stop at 14. So it did not include 14 because we said to stop at 14. So this is, if you think about like a number line, like a array, it would be like the filled in circle of 3 and then, or a segment, and then a line over to 14 with an open circle. So that would be like what that line segment would look like if you want to think of it that way. And then there's stepping. So what does stepping do? Well, let's take this 314 thing and let's add a step number. So now I have a start of 3, a stop of 14, and I did a step of 2. What on earth is this? Okay, so this says, hey, take this sequence that I sliced. So it's really take the slice of the sequence, and I want you to return every 2 characters. So it's going to go, okay, I skip, E skip, T skip, space skip, A space, or skip space. And we get I, E, T space, A space. So in string manipulation or sequence manipulation, you might need to slice something and use indexing and step through at certain points for various reasons. And you may never use this for the rest of your life, but it's something that is part of this what is possible. So I figured I would cover it. And yeah, so that's pretty much it for that slicing part. Now there is one little interesting way to do this, and that's what if you just pass a colon and don't give any direction? Well, it just returns back a copy of the sequence. And I'm using these words very specifically. So if you don't specify any parameters, Python just fills in all the defaults for you. So in this case, the start would be the start of the string, the stop would be the end of the string, and the step would be the default, which is 1, which means step through each character. Okay. It's actually a really easy way of getting a copy of the string, in this case S, and it's the same value, but if you remember the object ID conversation, it has a different object ID. So it's actually a copy. It's not, it looks the same. This sequence looks the same as this sequence, but S colon has a different object ID than S does. So just remember, and that's because it's read only, right? So we're actually reading that and returning something new. We're not actually obtaining that particular object with that particular object ID. So just know that string manipulation and sequence or sequence manipulation, if you want to think of it that way, is all just read only, and it's reading objects with different object ID and returning new objects. So that's something to take into consideration, especially as you get a little further down the road and you start doing like dynamic objects and dynamic creation of objects through like loops and stuff like that, where it's created them, a lot of them, that each of these objects address in the register of your memory and takes up space and can slow you down. So there's some things you need to consider when talking about scoping and namespaces and whether or not you're saving too much that you don't need later in your program versus creating a class or a function or something and using that namespace to create these objects. And then when it's done, it moves to the next part of the program and it can then mark that those addresses as not in use, and you can use that memory again. So yeah, basically it's kind of like the concept of garbage collection. So the last part for this video, because I know it's kind of long, is two things: string formatting, and then we'll go over tuples. So string formatting, very simple concept, nothing crazy here. There's you should just Google the documentation for string formatting because there's a ton of different ways to do it. But if I said greet old equals hello, and then I say %s, for example. Okay, so what does that do? Well, if I said greet underscore old, you'll see what the %s does here. Percent, and then my name, and I'm just showing you, you can use different quotes and stuff too. And I spell greet correctly. It says hello, Jake, right? That's one way of doing that. If you're trying to type something cool, you can also do some kind of like positional stuff where you're like greet positional equals hello, and then I'm just gonna do that. And then if I said greet positional dot format, and then I put my name in here. Let's see, what did I do wrong? Greet positional dot format. Oh, because I spelled my variable wrong. Hang on. I should really learn how to spell. It would make this a lot easier. Hello, Jake. So there's like 4 more different ways of doing this. Rather than me do it and then you forget about it and then be like, well, that was stupid. You can Google that and just know that there's different ways to position dynamic values where you can pass them and then they return them, stuff like that. So anyways, there's ways to do it without format too, and that's where you saw me use the F, right? So yeah, just Google that. Not worth watching this video over. You can just read it. You don't bookmark it and save it somewhere so you have it when you forget about it later. Okay. So then the formatting of string literals with F is the part I will go over because I think it's the most commonly used. And so here, if I say my name is Jake, okay, my age is 39, and I can say F and then go, hello, my name is, and then I can just pass in curly braces, name. And I am age years old, period. Something like that. And it will go, hello, my name is Jake, and I am 39 years old. This is, in my experience, the most frequently used one. So, and it's pretty simple. So that's the way that I'm going to show you to do it. There's other ways to do it with other stuff too. Like if I, from the math library, import pi and say F, you can do it without defining things either. Like I didn't define pi, right? I imported it. I could say the value of pi is, and then I can just pass pi like that. So you can use it with stuff that you don't define too, that's predefined and built in into other libraries like the math library, one of my favorite libraries. One of the other things you can do with F strings too, it's kind of a more recent thing, is to add equal sign specifiers. So if you're doing like user password stuff or whatever, you might see this where you could say the username is Jake and user is Jake, and then like my password equals something very secret, right? Then you can use F to say log in with, and then you can say user and password, and password, like that, okay? And what that'll do is it'll just be like log in with Jake in secret, right? But what you might want to do is you might want to add login with user equals and login with password equals, and you can do that. So that's just something that you can, that's a thing that exists that you can do. That's part of the F function. Okay, so yeah, go get the documentation, check that out. And then the last thing I'm going to cover, because I'm trying to do too much in one video, is tuples. So it's an immutable sequence type. It's basically a sequence of arbitrary Python objects. And when you declare a tuple, you have items separated by commas. And tuple meaning two, as in like there's two things. Think about it that way. They're used like all over the place. You can have patterns that are really hard to produce in other programming languages, and you can use them implicitly by saying like I have multiple variables, or you can allow a function to return multiple objects. And in some languages, you can only do one. So this is kind of nice where you can actually return two values, not just one, like a username and a password. I can show you this. So we'll do T for tuple, and we're just going to be like, I have an empty tuple, right? And the type of T is a tuple. Why did that happen? Well, by default, that's just what happens. Okay, so there you go. If I said one element of our tuple is 42, and I just leave the other one blank, I'm thinking about types. One element tuple has one element in it, right? And then maybe I have a 3-element tuple, because tuple doesn't mean that you have to have two, equals 1, 3, and 5, maybe some odd numbers. And then, yeah, I could be like A, B, C. Yeah, let's do A, B, C equals 1, 2, 3. You could do that. I could call A, B, C, and it will produce 1, 2, 3. I could say, I could find out, like, are there 3 things in the 3 elements tuple? 3-element tuple, and it gives a Boolean true. Yeah, it does have 3 things in it. So you can find out if something's empty or whatever. If you wanted to take 2 of those, it could be like, give me A and B. You could say, I need B and C. You could say, hey, C is now A. So now it's like A is now B, and change all the numbers, and B is now C. And then return like A, B, C, and you get, like, you can do all kinds, you can change them. You could do like all kinds of stuff. I could say A, B equals 0 and 1, and then go AB equals BA and go backwards, and then return them, and they reverse. So there's all kinds of stuff you can do. It's just a simple positioning thing, and to know, I guess the best thing is to know that it is possible to return more than one value using a tuple, and that if you create something that doesn't have a value, until it's defined, the object created, it will, like as you see here, has a tuple because I gave it an empty open and closed parenthesis. So that's an easy way to create an empty list of something or whatever. We'll get into lists and dictionaries and libraries and all that other stuff later. So yeah, this little trick of swapping values is super useful. So you can kind of put that in your little toolbox if you want to. So you saw how fast this was. The Python language is significantly smaller than other languages, and it's really, really, really fast. Part of that is because it takes advantage of being written in C, and it actually uses the C programming language on the computer where it's running, so that it doesn't have to define as many things inside of its own runtime. So this leads itself to be much more elegant, and you can do very complicated things very quickly and very succinctly, like I did here, of switching these numbers, positioning around like this in a tuple, which would be not so much fun in Java. So because these are immutable, tuples can be used for keys for dictionaries. If you're not sure what a key is in a dictionary, let me know, or Google it or whatever, and I can talk about it more. But for what our purposes are, the tuple is Python's built-in data that most closely represents a like a vector in math. Okay, it's not really why they were made. It's just the closest thing I could think of. Tuples have a heterogeneous sequence of elements, as we saw here. But lists most of the time are homogeneous. So tuples normally are accessed by unpacking them or indexing them, while lists are usually iterated over. So if you have a list, the way you'll see that, and let's say you had a list of groceries, right? The way you would represent that is if I had, here, I'll just do a really quick example. So clear Python. So if I made a list of here are my groceries. What I would do is actually use this straight bracket, because we were talking about indexing and slicing and stuff, and I could say apples, milk, bread, right? And this is, oops, this is a, these have to be strings, or else it'll be like, I'm looking for apples, and Python will be like, I don't know what apples is. Now it's just a string. So this is literally like a list, and lists are denoted with these straight brackets. Whereas if I made let's make tuple groceries, or T groceries, and I put it inside of here, and the same thing, apples, milk, and bread. Then I create a tuple, and if I call T underscore groceries, it returns what looks like the same thing, but one is in these straight brackets and one is in parentheses, right? And if you look at the type, right, if you look at the type of the groceries object, it's a list, whereas the type of the T underscore groceries object is a tuple. So just it's worth knowing. We're not getting into lists yet or any of that stuff, but when you go through a list, just like you're at the store, you normally start at the top of your list and you just go through it and go, oh, I still need to get bread, and then you walk to the bread aisle and you get your bread, and then you open your list back up, and then you go start at the top and you go, oh, I still need to get apple, and you just iterate through that list. Whereas with a tuple, you're very specific with slicing and indexing, like exactly where it is that you're trying to go, and you're not iterating through the entire list all the time, which can actually make things much faster if you're using tuples instead of lists. Not always. It depends. Sorting algorithms are a whole conversation all in themselves. Maybe I'll make a video about that. But so anyways, this is the longest video that I've had in this series so far, and I apologize for it being so long, but there's a ton of information I need to get into immutable sequences, and it will be extremely important. So make sure you practice understanding how to create tuples and lists and sequences and indexing and slicing and getting data types and lengths and doing other things. And I think that if you do that, you'll be well on your way to being able to do some pretty cool stuff here pretty soon. So let me know if you have any questions, and if not, then go make a sandwich and have a break, because this is a long one.